Taking a look at today's assignment, they're going to ask us about a new vocabulary term called a function. And all a function is it's a relation that pairs each domain with exactly one range. Basically, all that means is each domain has only one range. The domains do not end up repeating. So let's take a look at a type of problem where we'll see. Again, they're going to ask for the domains and the ranges and then to state whether it's a function. So let's take a look at this first one. We've got a series of ordered pairs. And one of those ordered pairs is 0, 2. The other is 3, 4, 5, 1, 3, negative 2. Well, the domains, remember, are the first numbers. That's what we talked about yesterday. And so all we're going to do is just list those first numbers. So we can write down domain. And when I look at those, it's 0, I've got 3, I've got 5, and I also have another 3. Now, it's not necessary to repeat numbers that are already there, but I'll go ahead and just do it since I wrote those down. If you just wrote down 0, 3, and 5, that would be an okay answer as well. Let's take a look at the next part, and that's the range. So remember, the range represents the second coordinate of the ordered pair. So the range is the y value, 2, 4, 1, and negative 2. And so we just list those numbers, 2, 4, 1, and negative 2. So those are the different range values. We've got the domain values. Now they talk about this function. Again, all a function is it's a special type of relation where the domains are not going to end up repeating and having different range values. And so let's take a look at our domains and see if any of those repeat, because then we'll know we've got a problem. 0 is one of them, then 3, and 5. Oh, we've got another 3. See, this point here and this point here have the same domain, but they have different range values. So that is not a function. And the reason it's not a function is because, and we also have to state this, we can't just say not a function, you have to state why. And it's because the domain 3 has two ranges. So basically, what that's saying is that when we input the number 3, we expect to only get one answer when we're dealing with a function. But here we're getting two answers. It's not that the problem's wrong or anything, it's just that that relation is just not a function. If we think of a function like a calculator, if we had a 4-function calculator, see, I use that word function when I talked about the calculator. Here's our calculator right here. Here's your number screen. And remember what they have. They have an addition sign, they have a minus sign, they have a times sign, division sign. That is a regular 4-function calculator. So if you were to type in 2 plus 2, that plus sign is your function. You're plugging in these numbers. These are like your input numbers. Your plus sign is going to give you the same answer every time. It should always give you the answer of 4. So it's kind of like pressing the button 3. I put in a 3 and I get a 4. I put in a 3 though, and here I get a negative 2. So what that's saying is this. It's saying, well, when I go ahead and plug in my number into my function, I have 2 plus 2, and it ends up equaling 5. You would say, oh, there's something wrong because the calculator must have misinterpreted this because 2 plus 2 does not equal 5. Well, that's the same thing here. This is not a function because when I go ahead and plug in a 3, I expect to get the same number every time. I expect to get maybe 4 here. But here I plugged in 3 and I got negative 2. It's the same thing here. This would not be a functioning calculator because here I plug in these numbers, I expect to get 4, but I didn't. And so a function is something where you get the same output every single time. You're not going to get a number like 2 plus 2 equals 5. So let's take a look at another example. Let's go with letter B. And let's say we had a mapping diagram this time. Maybe like 3, 2, 1, and maybe a 0, 1, and 2. And then the mapping diagram, remember, shows the domain values going to the range values. So let's say we had something like this. And they ask us, well, what are the domains and what are the ranges? Well, we'll just take a look at those domains. We actually already pointed them out to you. Can you remember which ones the domains are? Hopefully you said the domains were the first numbers, 3, 2, and 1. It's always the number that we start with. It's your input number. We're inputting a 3. We expect to get 0 every time. If we input a 2, we expect to get 1 every time. And those numbers, the second number represents, what is that called again? Yeah, hopefully you said that correctly. It's the range. The range represents the second component. So the range values are 0, 1, and 2. Well, 2 ends up repeating. Actually, I'm sorry, 1 ends up repeating because here 1 goes with 1 and 2 goes with 1. But you only need to write it one time. Well, let's take a look at that as a function. Is this relation a function? Well, a function says that every domain has only one range. Here, 3 goes with 0, 2 goes with 1. 1, we've got a problem here. When we push the button 1, when I input 1, I either get a 1 or a 2. That's a problem. So that means this is not a function again. Not a function. And the reason this is not a function is because of that domain 1. And you have to state that. And just say the domain, that is the problem. Which one is the problem in this case? 1 is the problem. The domain 1 has 2 ranges. So there is the problem. And again, it's not a bad thing for it not to be a function. It's just that it's asking which is a function. And those two are not functions. Let's take a look at another problem here. Maybe we have graphs. And we've got this graph here. I set up a coordinate plane. Let's say we have a point right here. And maybe a point right here. And a point right here. And so they're just asking for what those domains and ranges are. Remember, the domains represent the y values. And so let's write down the ordered pairs here. This is 2 spaces to the left and 1 space down. So we consider this -2, -1. This one is 2 spaces to the right, 2 spaces up. So we have 2, 2. Here we have 3 spaces over to the right, but 0 spaces up. So this is 3, 0. And so if I list those domains, I'm just looking for that first number. And so the first number in those ordered pairs, the numbers along the x-axis. So that would just be -2, 2, and 3. And then I take a look at those range values. And the range values are those numbers right along the y-axis, the points in which we have to go either up or down. And so here I'm looking at that second number, that -1, the 2, and the 0. And those are the ones that you write in your answer box. -1, we've got 2, and we've got 0. And then they're asking, well, is this a function? And so all we do is we say, yeah, this is a function because, you see, we don't see a domain repeating at all. Each of these domains is separate. When I plug in -2, I always get -1. When I plug in 2, I always get 2. When I plug in 3, I always get 0. There is no repeating domain. So we would say, yes, it is a function. It's a function. And the reason we say it's a function is because each domain has one range. And that's the key, is to know that each domain has one range. We say it is a function. Well, let's just take a look at the next two problems. Are going to end up being a little bit more challenging because they have lines or curves involved. Anytime you've got a curve or a line, we're going to end up having so many points we can't even count them, so we need to use an inequality. So let's take a look at this one. Let's use an open circle here and maybe a closed circle here and just draw a line between them. And so what we'll do is we'll list those domain values, and again the domains end up running along the x-axis. They start here at -2, and they go all the way to 2, to positive 2. So they didn't make it all the way to 3, just to 2, but it's an open circle on 2. So I need to represent the values in between those numbers. So I say that x can go from -2 to +2. And the values of x have to be greater than or equal to this number, because again, it has that closed circle and it's going bigger. The x values, if you look at this, as I go up this line, the x values are getting bigger. Y values are getting bigger too, but the x values are getting bigger. And that's what I'm dealing with in the domain. For the next part, though, x cannot be 2, and it can't be anything bigger than. So that's why I have to use this symbol. X is less than 2. So this means that the values of x are greater than or equal to -2, but less than +2. And the range values, well, those go from -1 here. So this is what I'm looking at right here, -1. They go from -1 all the way up to +3. And so when I'm looking at it, I start with the smallest number, and then I go to the biggest number. And range values are y, not x. So the values of y need to be greater than or equal to the -1, because it had that closed circle there, but they're less than +3, because the value at 3 is an open circle. And these domains, none of those domains repeat. See, that line is not going up straight up. If it went straight up, then we would have another domain that had a different range. It would be the same domain, but it would have a different range if it went straight up and down. So what we're looking for are any vertical lines. Any vertical lines are not going to be functions, but this is not a vertical line. It's a slanted line. It has some slope to it. So we say it's a function because each domain has one range. And we have to write all that out. It's a function, and the reason is each domain has one range. Only one range. Well, let's take a look at another type of graph. Draw a little point there, and then let's say it goes all the way over to this point, and then back to this point right here. So here's our graph. Now this one is different. It's different because it curves, or it cuts back. And so the problem with this, we'll just take a look at whether this is a function. We won't write the domain and the range. The problem with this is that we have domains that have more than one range value. So let's take a look at this. So if I draw a vertical line, right through this, see at this point, -2. So this domain of -2 has 1, 2 ranges. So this is called the vertical line test. If you can pass a vertical line through the graph and it crosses more than once, then we say that fails the vertical line test, so it's not a function. And so this one here has lots of failures. Here I could draw another one right here. See this one here, I can draw a vertical line through, and right through this point here at -1, it crosses more than once. So this one we say is not a function. Not a function. And the reason it's not a function is because it fails the vertical line test. And so the vertical line test just shows that that point there and this point here line up vertically. That means they have the same domain and different range values. Range values for this point would be 3, this one would be 0, but they have the same domain. So that means that domain of -1 has 2 ranges. So it's not a function. Now, those are the types of problems that we'll see on tonight's homework.